that was developed through a few different research topics kind of over the last couple of years, like since these LLMs have been released. And so last time we went over a few different aspects of, or what agents are, um, what uh, what agents are in general, like in the field of artificial intelligence and game theory, as well as how, like what LLM agents are in particular. So how they are kind of conceived of in terms of like what are their components, like how do you modularize different types of behaviors, and then also how that relates back to like the traditional definition of agents. And so this time I was hoping to give a fun example. I used Crew AI. I initially thought I was going to use Llama Index, but I'll go through some of my previous experience with agents over the last few months because I've been using them in a lot of hackathons. And so that's been kind of like my introduction to both like what they can be used for, and then also how quick and easy are they to put up, or is it kind of like complicated and do you have to like do a lot of like setup for it? And I would say that it's actually surprisingly easy. The issue though is that it's not always very stable. And so that's where like testing out different things is kind of coming into play. And some of these projects are like most projects that use agents right now are kind of in the POC stage, but I'm pretty sure that many of them are going to be moving towards more production ready applications. And so as like a quick recap also of what we were talking about last time, according to Russell and Norvig, agents are, an agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. And so in the case of LLM agents, their environment is essentially entirely text-based. It's like entirely virtual. So its perception is what it can read, and then its actuators are everything it can do with that information. And so that's kind of where some of like the lines between like actuating and planning are blurred with LLM agents, because in some ways, like it just thinking about the information is interacting with its environment. So so there are two main types of agents that people are usually interested in: goal-based and utility-based agents. Yes?
You may want to share your screen if you want.
Yeah, so I'm actually going to get to that next. I haven't, I meant to make a, actually, I can start writing this down. So give me one moment, I'll share my screen. Okay. All right, great. So as a recap, we have like the AI definition of agents, which work through I'll say perceive environment. Yeah. Through sensors and act on environment through actuators. And that there are two main types of agents, which are goal-based agents and utility-based agents. And so with LLM agents, as we kind of discussed last time, we can kind of like force fit it into this definition, but it's like not really quite so clear cut as just being able to say like we can create, that it has sensors, that it technically acts out on an environment. And yeah, we kind of had like a longer discussion about that last time. But yeah, like LLM agents in particular, they use like a structured prompting system. Which recursively, we'll say 2, 3, yeah, actually, yeah. Which recursively calls an LLM to execute complex tasks. And LLM agents also usually have, they're usually hooked up to tools. They have like a memory storage. And that they also make use of the reasoning capacity of LLMs to do planning.
But the problem that they don't fit in this definition is that they do not change the environment. They can act based on the information from the environment, but they do not make changes in the environment.
Yeah, so the it's kind of a little bit more complicated because like with the LLM agents,
Yashila, sorry for the sake of the listeners and also YouTube, the question doesn't come out. If you could repeat the question, that'll be great. Thank you.
Yes. So one of the members of the audience, could you?
Sam Mirazi.
Nice to meet you, Sam. So Sam asked, is the problem with the definition of agents that it does not actually act on the environment? And the answer is, it depends on who you ask, because like some professors would basically be like really hardline about it, that the only agent that's really an agent acts in the real world, not in like a cyberspace. And so in that case, like what defines like what is reality to them is like a little bit more complicated. Like, do you need to have a robot to have an agent is like one of the things there. The other part of it is something that you kind of hinted at like in your question and said in person that I didn't say in like over the speaker, is that does it actually act out in its environment? So like it can perceive text, for example, but is it actually able to manipulate, say, the text or manipulate the underlying data that's there? So these agents can be configured to like manipulate data. And then in the planning phase, it can even run experiments, which is like, depending on the agent, it will do so or will not do so. And so, yeah, I think it's also kind of complicated because defining a clear goal for LLM agents is not very simple sometimes, because you may not know what you want ahead of time, like when you're defining these agents. And so can it really be a goal-based agent if your goal is open-ended? And then also similarly speaking, can it be a utility-based agent if your kind of heuristic or like the things that you want it to do, not necessarily the goal, but the way you want it to behave, change over time? And so, yeah, so these are kind of like the complexities of like making these things in real life. But I would argue that at least the conceptualization of like goals and utility and acting in an environment is really useful in being able to set up these systems to begin with and kind of understand how we should be prompting them. We can go a little bit more into that maybe a little bit later. Yes?
So is LLM agents a part of AI agents, or they are two separate kind of hierarchical agents?
So AI agents is just kind of like a general term. I'm just using this as like a theoretical term that I borrowed from like a really famous like introduction to AI book. But LLM agents are kind of like the the word that a lot of people are using to talk about the structured prompting systems that are currently there for LLMs. So whether it's truly an agent in like the traditional term of an agent or not is kind of, it's something that you could argue, but I would say that it's maybe not like like the core, I don't know, it's not like the most useful thing to think about. Yeah. Any other questions or any other outstanding questions from last time that I may not have answered?
Would you consider those, are you familiar with OpenAI custom GPTs? Are you familiar?
Yeah, so I kind of know a little bit about them. It's like
Would
this,
you consider them as agents?
I probably would not.
Yes.
So
One-
in
I mean, like even in this case, right, when you said LLM agents, whether they act out of the environment, they kind of, people now kind of modify the definition that if you have an LLM agent, write a poem, sell it in an online action, and get a money on the PayPal account, does it effectively make a change in the world or not? So that is the definition under which custom GPTs are actually being looked at. Can you make a custom GPT that actually sells and creates art and sells it in auction? Can it be an agent? Not yet, right? Because the agentic framework, I mean, at least that my definition is that if you want to define an agentic framework, you just need to create some kind of like a goal so that you can take autonomous action, which can create a decision basically by dividing a problem into subroutines yet. So that is something which OpenAI is working on, but the current custom GPTs do not yet allow such an environment.
I would say that OpenAI assistants, for example, like those kind of constitute agents.
Yeah.
So you can use those GPT like for the assistants, but like the GPT basically only defines the behavior. Actually, last time we did talk a little bit about this, like in terms of what an LLM is in relation to like the agent itself. And essentially, like, yeah, within like the Norvig definition, they basically say that like an agent is like an architecture and a program, and like that agents can have like an agent programmer function, which is basically like the core behavior that like the agent can then use to like perform an action. So like the agent is not just like the algorithm which defines it, because usually these things like have an algorithm that sits behind like, how do I define utility? Like how do I make a decision between like two different options? And that algorithm to figure out which option is better is not the agent itself. The agent is actually the one that executes like on top of that, right? Or the instance on
the action.
Yeah.
It takes actual action.
Yeah, exactly. So if, for example, you give like this GPT the like a goal, you tell it a goal, like it needs to go execute on this. If it's like then going and executing on that goal, that instance of the GPT, I would consider an agent. But the GPT itself is not an agent. It's just like an uninstantiated like class, basically. So yeah, I
Sure.
think.
So Yashila, it's kind of going back to the quick question. I know we are cutting time into your rail. It's going back to the earlier discussion last 2 weeks ago. So if you look at the definition that you said, perceiving and acting. So perceiving is an agentic activity. Then the perception is sent over to the LLM. LLM creates an options, whatever the optioneering, and then after that, the agent takes the right action. So where is the kind of response domains here, domain division?
Yeah, so that's what I meant by saying like these are kind of like difficult to make very explicit with LLM agents, because in some of the intermediary steps, for example, that the agent would do in the planning, like if the agent is just planning to itself, is that really acting in the environment? But if the environment is the text that it's producing, yeah, it's like acting and then also acting on the environment at the same time. So like in eliciting a response, like it's kind of like creating in the environment itself, which is like a little bit backwards with like the original conception of an agent, of that it kind of like it thinks internally and then it acts, right? But with LLMs, it's producing text like while it's thinking.
Got it. Yeah.
Yeah. So, it's not like a one-to-one correspondence. And I think it would be interesting to kind of like maybe define like a more explicit, I don't know, relationship between the two definitions, like maybe a little bit later. But yeah, I kind of wanted to go a little bit more over like what yeah, what are the practical considerations of like actually making agents like using like an agentic framework today?
Right.
Another question?
Are you asking the audience?
Yeah, I thought, no, never mind. Okay. Yeah, so, yeah, so for like making LLM agents, as many of you probably know already, like a lot of these like LLM frameworks are all in Python. And so kind of like the core thing that you would need in terms of the stack is Python. The next part of this is basically like, where are you hosting the LLM? Because in practically all of like the, yeah. Okay. Yeah, in practically like every case, you're essentially like hosting the LLM like at some kind of like API endpoint or like some kind of callable endpoint. And so I'm just gonna write that down as LLM, but like you can have it run locally on Olama, or you can use like kind of microservices like through different cloud providers that also offer this. So like Google will have Gemini through Vertex, and then I think Azure has like its own set like offered through Azure. And then of course like OpenAI has its available on OpenAI's like API. And then there is Anthropic, which has its own API, or you can access that through Bedrock, which is like Amazon's like AWS platform. So I'll just like quickly write those down. So we have Google with Gemini. Um, uh, and then we have Open AI, and then recently NVIDIA released NIMS, and one of the engineers who was working on that project is like currently sitting with us in support vectors today. And then NIMS has Llama 3.1, I think, right? Yeah, and then yeah, you have like a couple of others like Fireworks and a few others like that. So yeah, you have like tons and tons of places where you can essentially get this from. And I think that in terms of like which one you use will have to depend on what your yeah, cost considerations are, because some of these like rack up, like they are very expensive. Like OpenAI costs tons of money if you're using it for agents in particular. And one of the really important things to remember about this is that for agents, it will be making a considerable amount of LLM calls. So if for a single action that the agent takes that you tell the agent to do, it has to make like 100 calls or 200 calls, then you have to start being a little bit cost efficient, because it's not so straightforward as I'm going to send off like one request like to OpenAI and it'll like give me like a $1 charge for the one request and then it's finished. It's possible that if like the agent isn't set up well, it'll take like hundreds of requests, which will make like a single task like very expensive. So I personally like to use Olama a lot, not just for, I mean, if I were to actually like create like a production version of this, I'd probably be using something a little bit more stable, like yeah, maybe like AWS or like NVIDIA NIMS, or maybe even Fireworks, because I've used that previously and it works fairly well. I probably wouldn't be using OpenAI because it's pretty expensive. But to do like local development, I would use Olama because that runs like on your computer. And so it's like pretty useful to kind of have like at least a testing environment where you're not like incurring any costs around that. It can be a little bit slower than like running it on an actual like cloud provider, because like your computer only runs so fast, and you need to have, I think, more than or 16 gigabytes of RAM or more to run most of like the 7B or 8B models. And so that's also another consideration that you should have like when you're running locally, is that you do need to have like a sufficient amount of RAM to run it in the first place. You can also try to use like some of the smaller models which are there, like the I think Gemma has like a 2B or 3B model, and then there are a couple of other like 2 or 3B models that'll work on like computers with smaller RAM. But then again, if you go to a smaller LLM, it'll have a smaller context size, a context window, generally speaking. And then also on top of that, the reasoning capacity will be limited, even more limited than with the 8B model. So yeah, lots of considerations in terms of like which LLM to choose, where to host it, everything. That is actually something that becomes like a big part of like how do you construct like what LLM you want to use, or like how you're gonna put like the agent together. Yeah. And so the next part of this is that so you
Just wanted
have
to let you know, I think Gemma just released 2B this week. Lightweight 2 billion 2B, Gemma 2.
Oh, nice. Cool. I know
Yeah.
that they have, I think, a 3V version. Or was that or I might be thinking about Phi. I know that Gemma had like a small version already, but I know that Phi was also there, like Microsoft's like
This is brand new. I think released yesterday or so, or the day before.
oh,
Gemma 2. Gemma 2.
oh
2B though. 2B.
nice. So yeah, there's that can actually also be like a prolonged discussion about like what LLM, like which LLM and then which sized LLM to use, because they all kind of have like their own strengths and weaknesses, and I'm not really sure if there's been any like truly comprehensive benchmark on the reasoning capacity of like all these LLMs, which is for agents very important, because like the more limited the reasoning capacity, like the more constrained the problem that you give it has to be. Otherwise, it's not going to be able to execute it appropriately. So yeah, we have Python. We choose an LLM. The next part of this is that you're probably going to want to have a Lang chain, even if you're not using it to define the LLMs, because this is really useful in making the tools that the LLMs will be using. And then more than that, you can abstract away some of the tasks that you would otherwise have the LLMs do, so that you can say like, give it like a text extraction or text formatting task that then gets like kind of like offloaded onto like a LangChain function, as opposed to having like the agent do it. Which, going back to the reasoning and planning capacity, is like very important if you have like a really small LLM, or if you're like running on a constrained environment, because you want to be keeping the agent do as few tasks as possible, like within a given step. So yeah, LangChain is useful. And then like and then you can also do, actually, let's go into like the different frameworks which you can use here, which is also a very long time, like where you can choose LLMs. Like the second thing that like takes up a lot of consideration is like which framework to use, because there are many. So in terms of I'm actually, yeah. So would take a screenshot now. I'm gonna like open a new page.
Yashila, someone, as Mike has said, can you use a thinner pen?
A thinner pen. Okay.
Yeah.
Yeah, I'm not sure how much of this is a thinner pen versus a thicker pen. My handwriting is also not very good. So yeah, going back to the stack, the next thing is the framework which you would be interested in using. So LangChain has its own set of agents. I would say that LangChain's agents are like not particularly good. So it's actually now LangGraph, but LangChain had also like its own agents. But the LangChain tools are yeah, they're pretty good. Also, like, so yeah, so the second one that I would say is like pretty high profile and that practically everybody uses, but is a little bit more complicated to learn than the other ones that I'll be mentioning, is AutoGen. So this is like, I think it was Microsoft who did this one. So yeah, AutoGen has been kind of like the standard for like a lot of like POCs for different agents. I would say that the one complexity behind it is that setting up agents in AutoGen is like a little bit of a pain, because the way that they conceptualize tasks is such that each agent can only have one type of task. And then if you wanted to do like multiple different types of tasks, you have to create a sub agent for like a different agent. And so that can be a little bit annoying after some time because you have to kind of like construct it in that way. Another one the one that I will be using today will be Crew AI. This one I really like from like a user experience perspective because it's really easy to set up agents and the code looks very clean. Crew AI is actually based off of LangChain though, and so it has some of the same limitations that like the LangChain agents also have. And so while it's easy to set them up and like test different things out, one of the issues that I've run into several times with Crew AI is that like if you have multiple agents that are kind of trying to negotiate different tasks with each other, they will sometimes end up getting into like recursive loops where they'll constantly be saying the same thing to each other, like step after step after step. So that's a little bit annoying, and yeah. And then the last one, which I've been meaning to try out, but I haven't tried out yet, is Llama Index. And so this one you might actually recognize as like one of the tools that's there to create like the indices for graph databases, which is kind of like one of the main use cases that that library has. But it offers like a wide range of like different like LLM related functionalities, and many of them are kind of like in direct competition with LangChain. So you might see like the same types of functionality available in Llama Index as is there in LangChain. And then depending on like which libraries you're using, you might want to use one over the other because some of them, many libraries kind of assume that you're running LangChain like on your computer. And so that can be kind of complicated if you like try to use Llama Index to do something that LangChain would do like with a particular library. In most of those cases, you can usually cast whatever call you're making in terms of Llama Index, but again, it just adds extra code and extra complexity. So it depends on what you're doing. So yeah, so those are the main four. There are like a ton of other ones if you're going to go look it up online. There are some which are a little bit more general. So like instead of like defining this is the agent task, this is the underlying LLM, this is like how I'm going to integrate with like a RAG framework, this is how I'm going to set up like a vector index. These all will allow you basically like full control over these things like through coding itself, and all of these are available through Python. There are a few which don't actually like integrate like that well into Python, and so they basically are just like text-based agents that you'll call like over your terminal. And then that includes, I think, yeah, that includes like ones like I think, yeah, like Auto GPT or like multi GPT, and then Mem GPT was like another one, and then also like some of these cloud providers, like AWS Bedrock, for example, also offers like an agent functionality where you can define agents like through the UI on their website. And I've tried that a couple of times. It doesn't really work very well, but I think that maybe it'll become easier in the future. So yeah, so this is kind of the stack. And then, yeah, going back to our discussion last time, there are different points of view in like defining agents. Some people say that like you should define agents very strictly, and I would and like last time we kind of talked about like reasons why or why not you would, or why you would want to do that and why you wouldn't want to do that. So if you want to give the LLM like much more range of being able to plan out like a particular task and like do different things, you'd probably want to attach like a much larger LLM to that, because then it'll have the appropriate reasoning capacity and it's not going to start hallucinating halfway through its like planning sequence. And it would give it more flexibility in terms of like the different tasks that it would be able to solve, and potentially be able to deal with unexpected errors that it'll encounter along the way. So it would be able to kind of like compensate for like different environmental factors a little bit more easily. At the same time, if you are pretty confident that certain tools and like certain types of data will always be available, that it'll always be able to reach like certain types of API endpoints that you tell the agents, it might be cheaper and also like a lot easier to just like define a very or to very clearly define an agent with a super specific like goal and a super specific output and a very specific set of tools and data available to it. And so yeah, depending on which of these you would be So the ones that I've listed here, like LangGraph, AutoGen, QueryAI, Llama Index, they give you a lot of fine-grained control, but like creating a much more general agent, I would say, is like not really effective to do like in these frameworks in particular, because they're kind of made to do like very specific tasks.
We were talking about the previous, the last.
Oh yes.
We're talking about the expenses. So the Llama 3.1, that is like open, so that's clear. But usually we don't expense. That's it.
And yeah, and
No, I think that was really for Facebook, but again, there are two things, right? So now you need to have the local environment to download and run it. So you could either download it. I think when Yashila was mentioning about expense, you offload the online inferencing, and OpenAI was well known to be expensive for online inferencing. Otherwise, you would just use Llama, download Llama 3.1, like 7 years. I mean, because one thing to note is that Gemini 2, actually, the one we discussed that came out, apparently it's 2.6 billion, so just rounded down to. And because apparently they did a demo on even you could run it on a Raspberry Pi. So it's such a small model, you can run it on a board actually.
yeah, and this is like one of the other interesting parts about this is that like if you're trying to do something in the cloud, for example, you'll have a lot more space to run a much bigger model. But say you want to do something at the edge. So in that case, like you might want a quantized version of like say Gemma 2 or like Phi 3, which is like the Facebook or not Facebook, the Microsoft like 3 billion parameter model. And so those are small enough that you could actually run it on your phone, probably comfortably. And so that's pretty interesting because like.
Wouldn't another approach be to pick a smaller model, but then upload your own document, like RAG, retrieval augmented generation?
Yes. And so that's the point of like some of these like frameworks is that if you have like a very clearly defined workflow that the agent has to take in order to essentially like achieve a particular goal, then because so what happens with the smaller models is that essentially like if you give it too complicated of a task, it doesn't have the ability to like reason through all the steps of planning out what to do. It'll essentially start like hallucinating at some point or forgetting parts of the instructions that you give it. So for those, oh yeah, I don't know if everybody heard in the crowd, but like Sam was asking whether we should, whether if we could take like a small model and then say like upload our own documents to it, and if that'll be like faster than running it with like a big model like in say the cloud. And so my answer to that was essentially it could be, and that's especially true if you have like an agent with a very clearly defined goal and a very specific goal in a very constrained like environment. And like these frameworks will essentially like enable that for you, which is why I was kind of like going over them today, because I feel that like one of the other concerns that a lot of people have around these agents is like, does it have consistent behavior? I'm not just interested in whether I can get something done once, right? Like if I want to create a workflow, I want it to work every time that I try it, right? So I want to actually be able to see, like, can I ensure the behavior, like some way, shape, or like in some way, so that I know that it'll work like a certain amount of the time? Can I create like a I don't know, like a kind of like service level agreement, like on how well this performs. And so this helps. And then the other thing that I was going to introduce is like another technology, or not another technology, but another package called Pydantic, which does strict typing in Python. And so essentially like this kind of works as like your, you can create kind of like unit tests for the outputs of like the LLMs like while you're running it. And so Pydantic will let you do that. And then LangChain has the ability, like you can use LangChain to essentially like enforce that you have like a particular like Pydantic output to your agent calls. Okay, yeah. So yeah, this is the stack. Does anybody else have any questions about this? Okay. I'm gonna keep moving. I really wish I had taken a little bit more time to put this into a presentation. So yeah, so we were kind of hinting at this earlier, but I would say the next thing is kind of like what I would generally keep in mind when you are when you're defining agents. Especially when you're using like one of these frameworks and you're using, I mean, even with like the larger models, like if you're using like a 70 billion parameter model, like you'd still want to be very specific, like with your tasks, because the issue with smaller models is that they hallucinate. One of the issues with bigger models is that if you're not specific enough, it'll give you very generic answers. And so in either case, especially like when you're using one of these frameworks, you need to give it some level of like structure and specificity, like when you're defining at least the problem to yourself, and then that helps you create the prompts like for the LLM. So yeah, so the first thing is like always be very clear on like what your task.
Yashila, can I ask one question?
Yes, of course.
Yeah, that's great one, great presentation. So my question now is, why do I need to use a framework? Why not? I can build the, whatever the agentic framework, agentic reasoning, all by, using the basic capability that Llama Index or LangChain provides. So what is the advantage of using a higher level framework?
So I would say, Krishnan, for like Llama Index and LangChain, you can try to create like the recursive prompting yourself. In fact, like Llama Index is really interesting because I would say that it kind of sits in between. Like CrewAI, it basically like abstracts away all of this, but like Llama Index allows you to like change anything that's like there for any of the agents, and it exposes a lot of like the underlying mechanisms like to create agents. And the same is also true to some extent for LangChain. Yeah, I think that LangChain's a little bit more complicated because like if you're doing something very particular, then the difference between creating a function with an LLM as the backend and then also creating an agent in and of itself is like almost the same, because you can essentially like create very specific workflows like in LangChain that is just like executing on the agents, but then also the outputs of the agents that you expect is like what's creating like your final output there. I think
those frameworks, does it provide like a predefined functions or
Yes, so it actually provides some predefined functions, but it also allows you to make your own functions, and it has like a really specific way of doing that. And LangChain in particular is that like you should be able to chain together the functions. That's why it's called LangChain. And so that's kind of related to like agents in general, is that you want to have the agent continuously calling itself in order to execute on something.
Calling itself and also calling other agents.
Yes, yeah. So you'd want to have like almost like a live version of this. But then say, for example, you're looking at some of these agents as like microservices that are being executed like on an API. Then it like the line is kind of blurred there, because then if you have like a series of functions that you're calling through a microservice and they're all calling each other like through different APIs, then you would have such a tightly like bound like workflow like between the different LLM calls that it's not really an agent like if you're running them one after the other, but it looks almost the same. So
True.
yeah,
At the back, yeah, correct. The way I was thinking, so all these agentic framework obviously provide some value, right? It enables the agentic reasoning for the application developer. So that means, the way I understand, in multi-agent scenario, there are a lot of things you need to be taking care, right? Tracking the other agents' responses, and then, replying back to those agents. Things like that is what the agentic framework layer provides. Is my understanding correct?
Yeah, I would say that. And then also one of the other things that the framework provides is like, you don't have to actually think about the underlying mechanism for how it's doing like the recursive calling. So I think
maybe we are talking the same thing, right? Yeah. Okay.
Yeah. So there are reasons why you would want to like kind of like go and operate, like essentially like do surgery on an existing agent to like replace some of the functionality with something that you're interested in. This is especially true if you want to change like the way that it's doing planning or the way that it's storing memory. Which, yeah, like if you're using say like AutoGen or CrewAI, it can be a little bit complicated, especially with CrewAI. I don't think that there's a way for you to define like your own memory structure. which is not ideal if you want it to do something really complicated. But at the same time, if you're doing something very simple, then it helps to have that abstraction, because then you can write your code very quickly and kind of iterate on at least the prompts for the agents very quickly. And then you can try to take that and transpose it into like one of these other frameworks and then play around with some of the other things that are there. But yeah, to begin with, like regardless of whatever you choose, whenever you're making an agent, you should be very clear about like the tasks and the outputs that you expect, because you need to be able to test the outputs to make sure that it's like behaving appropriately. And then also you want to kind of understand like, you know, is it actually completing the task that you want it to complete? And yeah, so that's like the
yeah, you can almost think about like it's a difference between library and SDK. I mean, if you decide to develop an Android app, you could actually use using Dart or Flutter library, but there is an Android SDK which kind of provides a structure to the how you want to develop. Similarly, these agents, these frameworks provide structure to recursively create it. And you can also, it can be bootstrap, like how do you create a task or how do you chain together your agent? That's something that is already built in the framework. So most people just bootstrap the framework, and then you could customize it.
But in theory, you can do all.
You can do it directly with the, you don't even need, so basically you could just use OpenAI and a light LLM library. You could actually directly use it and do it. But this provides a, yeah, exactly. So that's why it's like an SDK versus library.
yeah.
What's the environment in this thing? Because it's open. Anything can be done. What are we talking regarding agents act on a particular environment? What does that environment entail?
So in this case, like the yeah, so when we're talking about like the tasks and the output, like the direct correspondence to this is like, what inputs am I going to give the agent to begin with, right? Like, is it going to be given like a JSON? Like, is that the data that I'm providing it, or is it going to be a text, or is it going to be an image? Like that has to do a lot with like what you want the task to be, which again is like one of the complexities behind like, yeah, what we were talking about earlier with like, how is this actually acting in the environment? It very much depends on the task that you want it to execute. But I would say in this case, like the environment is actually like, what are the inputs that you're giving it? And then like, what are the outputs that it's getting? Yeah, so being clear about like the tasks and outputs. I would also say like, be clear about, well, yeah, given that, then you can start choosing like what your stack is going to be. So like, depending on like what your task is, then you can start thinking about like, given that this is the task, like, is this a very specific task? Can I execute this like with the smaller LLM? And do I have like, I don't know, like some resource constraints that I don't want to spend too much money on this, and so I want to run it with a specific type of LLM? Yeah, it's kind of a little bit complicated to figure out like what is the cheapest way to run a specific task, because like the more complicated it is and the stupider the LLM is, then the more calls it will make, because it has to essentially do even more planning. But if like it's a big LLM, like a very intelligent one, like 4.0, for example, like GPT-4, right, is a very intelligent LLM. It can do almost everything in one step, but still you have to run it for that one step. You still have to make that one call, right? So if you give it a very vague like prompt to begin with, then it might sit there and call itself like 50 times, and then you're kind of like, you know, you end up like losing a bunch of money on it. But at the same time, if you know that like your LLM is capable of doing this task and you've like defined it very clearly, like in the prompt, then you can like run it with a big LLM, and it might be cheaper than say trying to give the task to maybe a 7B or like 2B model, which may not have like the planning capacity to do that very efficiently. So yeah, first be clear about your task and output. And then the second part of this is like, you want to be clear in your prompt for your task. And then this kind of can be broken down into like a bit of a prompt engineering problem. So there's been like a lot of talk about prompt engineering in general, and there are a few different frameworks to like making good prompts. So there's like yeah, like in Asif's class, like you kind of go over a lot of prompt engineering, which I think is really good for understanding like how LLMs like function in terms of like how they break down prompts and how they kind of like um yeah, how they break down prompts, how they basically like interpret questions and stuff like that. But I think like most of these like frameworks will essentially like break it down into you have like an agent prompt, which I think is and then you actually have a task prompt. And so in this case, like what you can think about, like in terms of what we already have brought up, is like the agent prompt is essentially like the heuristic function that you're making for a particular LLM agent, right? So if we go back to like utility versus like goal-based agents, your goal is the task, right? So this is like your goal. And then your utility is like how closely the agent is behaving to the way that you're asking the agent to behave. So this is like your utility, it's your heuristic.
And when you say prompting, you don't mean coding prompting, you mean like the actual.
Yes, the actual text, right? And so in this case, like yeah, when you're giving your prompt, you should be like have very precise language, and then also try to be precise and then try to be concise at the same time. They're just sometimes difficult to achieve because these are sometimes like conflicting like limitations to place on a prompt. But
we can provide examples like for this input, I expect this out.
Exactly, yeah. So yeah.
Yashila,
So
can we see this is getting a little esoteric? Can we see actual code to kind of ground these things?
That's the next step. So yeah. So yeah, we'll be
Thank you. Yeah.
Um okay, yeah, let's just switch over into code then. Give me one moment to log into Zoom from my computer.
I'm excited to see as to how you wrangle data between various the plan. Once you make the plan, I'm sure there are multiple, just like function calling. There's a main loop that you call multiple functions, and you get some data. You wrangle the data, send it to somebody else. I'm interested in the data wrangling part too, actually.
Oh yeah, I mean, yeah. So like the example that I have kind of has to do a little bit with data wrangling, actually. But I don't have consent to humor as part of it. But that is something that you can kind of do like once you have like the output that you expect. The last thing that I wanted to kind of mention here is that once you have like the prompts that you kind of want, or like once you have the general idea of what you want to see, then it's actually really useful to use an LLM to generate the prompts that you want. You can have an LLM generate what the actual agent prompt is going to be, or the task prompt is going to be, which I think is like really fun because then you don't have to go through like the effort of like, how do I be concise? How do I be precise? Like, how do I like have like a good style like when I'm writing? There's no need. Like you can have like an LLM do it for you. And then more than that, once you have like the agent prompt and task prompt set up, then you can actually use like the both of those to ask an LLM to generate like example data for you, example inputs and example outputs. And you can also kind of like play around with like what you want your output format to be, also using the LLM. So I think that that's kind of like the fun part about this is like once you kind of have a good idea about like what your task and output and kind of like what exactly you want the agent to do, then you can kind of like wordsmith your prompts like using an LLM. Yeah.
You still lost the audio, are we?
Oh, hi. Hi, Yashila. Are we
Okay.
okay?
All right.
Okay, we're in.
All right. So yeah, I'll give you a quick walkthrough of my like Crew AI code. This is based off of the boilerplate code that they have on the Crew AI GitHub page. And it's pretty simple. So like the reason why I like Crew AI, especially to test out like agent functionality and like making agents in general, is that like the code looks very clean in my opinion. Yeah. So usually with Crew AI projects, like you'll have like a main.py where so yeah, the idea behind Crew AI is like it's a multi-agent framework, and so you don't just define one agent, you can define many agents with many tasks, and in fact assign different multiple tasks to like one agent or something like that. So you can essentially like reuse some of like the parts for this. And so all of the agents like are kind of put into a crew, like they're aggregated into a crew, and then like the crew itself will have like an overall goal. So usually it's just to execute the tasks one by one, but I think that there's like a slightly more complicated like task execution hierarchies now than there were when this first came out. And yeah, so essentially like for the crew, like you'll define each of your individual agents. In this case, I have like one agent and one task, but I was thinking of like maybe adding another task like while we're here. And so, yeah, so the main is just kind of like you import your, you import Crew AI. I have like text wrap just for like the format of like the code itself. You import your agents, import your tasks, and then instantiate them. So just instantiated. And then the task takes in an agent, and then also a couple of variables that I'll be prompted to put in from the from command line, like when I run this. And then I create my crew, and then we can like run the crew and return the result. And so for the agent, it's a very simple agent, which is supposed to be an entity extractor. And so in this case, I thought it might be fun to give you an example of like something that's really easy to do with LLMs, but is actually quite hard to do with like traditional like NLP things. Is like trying to extract entities from text is really difficult. And then also, like, what if you don't know like what properties are there like for the entities that you want to extract? Like, what if I just wanted to give it any text and then just extract some properties like from each entity that it encounters in the text? And so yeah, the idea is essentially that I would define an agent that is able to do that, and then you can just tell it what you want it to do, and if it kind of is a verbal reasoning task or verbal reasoning oriented, then it usually performs these tasks quite well. And we talked a bit about like what the limitations of like LLM reasoning were last time. Yeah, so this is my agent. So you extract entities from text and return each one as a JSON object. And then the task itself is essentially the same thing, but yeah, so the goal is that you extract entities and return each entity as a JSON object. Make sure to extract all entities, but only return one entry per entity. And then I gave it some steps to do so. And also that the user might be able to add properties that it is interested in as well. So we'll test this out when we run it. And yeah, and then return the output in a well-formatted JSON. And here are some examples that I actually asked like Llama 3 to generate. So really simple text. John Smith, CEO of XYZ Corporation, met with Jane Doe, a prominent investor. So you have the entity John Smith. He's a person type. He has the position CEO. And then you have Jane Doe, who has also the person type and occupation of investor. And this is one of those cases where it might be useful to add some more like verification, some more controls on this, because in theory, these two should be the same. Like position and occupation should not be two separate types of properties. So yeah, I have a few examples like this. So yeah, and so yeah, would anybody like to give me some text to put into here, or should I?
Describe our room right here. We have a great group of, we have a great group of AI enthusiasts.
All right. There is a group of AI enthusiasts at Support Vectors who are listening to Yashila present on AI agents. And then I'm not going to have it extract any properties. Oh yeah, here's like a fun little tidbit. If you like, so with some of these, if you either threaten it or tell it that you'll like give it like a huge commission or something like that, it actually gives you more precise answers.
Oh,
Yeah, so you can bribe it, even though it technically shouldn't have like any conception of what a.
And is that part of your prompt somewhere?
Yeah, it's a part of my prompt, like in the tasks section. So interestingly enough, it didn't extract like any of like the places or anything. It just extracted me, and I think it's because it recognized me as a proper noun.
What else you were expecting? Yeah.
I was actually expecting support vectors to at least show up as a either a location or also as like something else, but it recognizes me as a person.
So if you said that at location or something, because support vectors could be an algorithm.
Say a Starbucks. Change the support vectors to Starbucks and see how it goes.
Yeah, let's try that. And yeah, and the other part of this that I would like to kind of say is that I just like wrote all these prompts. It's not very specific either. So it's possible that like by changing the prompt slightly that we'd get like a better detection of like different objects which are there.
What you mean is meaning of understand.
Because support vectors one of them got.
Oh, there is an algorithm called support vectors. Yeah, that's what.
Oh yeah, I can take like the previous test case that I have as well. We'll try this. We'll try that one next. Let's
try this version first.
Yes.
Yashila, in this example, how is the task there is an agent and there is a task, right? What is the difference in what the agent is doing versus what the task is doing?
So essentially, like if we're talking about the agents can do multiple different tasks, but they're the same. So essentially, like first we want to define like the agent behavior, which is kind of like your heuristic, like if you're like looking at this as like actually being an AI agent. But then like the task is actually the goal that you're giving it. And so in like many different frameworks, like it has this kind of division between like agent and task prompts, but when you like give it to the LLM, it's the same. You're just appending it all like into the same prompt that you're sending to the LLM. And then the agents can modify like the task prompts that they give, like whenever it's doing like the execution, like under the hood, because it might create like subtasks that need to be achieved in order to get the super task to actually be executed.
But isn't that amazing? You can do this just by writing the text, not the actual code. And this is not a simple task.
This is actually quite a complex task for like an NLP algorithm to do. But this is, like you guys see this is not exactly like rocket science code here. Yeah, so yeah, let's say
in this example, suppose you had not given any task, would the agent have still done it? Because agent has a goal defined, right?
Yeah, so in this case, like I think that this is one of the weak parts of Career AI is that I don't think that it should have a goal if like a task is defined for the agent. But in Crew AI, you need to have like both the task and the agent be defined.
Okay.
Yeah. I don't know if that answers your question, but like I think for like autogen, for example, like it wouldn't have like this like goal as like one of the properties for an agent. Like you would just like set up like the role and like what it's supposed to do. So here it says like role and backstory, but like generally speaking, you would have like an agent prompt, and then like you would have all of that be like one input.
Okay. Thanks.
Mhm.
Yeah, no worries. Oh, okay.
What does their GitHub sample? What is it about?
The GitHub example is like, I made a couple of, I forgot exactly what I changed because it doesn't actually work out of the box anymore. I think that they updated Crew AI and then like that changed the way that you have to interact with different things. But I also imported Olama. I have like my own definition of Llama 3. So the other thing that you can do with Olama is give it some like system prompts as well. So then you have you can place like guardrails in the system prompt like in Olama, which are separate from the Crew AI code. So you can essentially like hard code like some of the behavior for like the model that you're interested in. Yeah, so this is basically like all the same. I think the other thing is I made like another, I think I edited like the task here. I changed the expected output, I think, and then I I don't remember if this, yeah, I don't know. I don't have any tools at the moment, but you can like add tools to do some other stuff. Like for example, if you're doing this, you could also have like another, we'll talk a little bit about like how we can kind of like change the outputs, but you can have like another agent kind of like go look up different entities that are extracted and then like pull in like web links for references for like different objects that you see here. Yeah, but I would say that that's like the Crew AI code is like pretty, I don't know, it's good boilerplate code, I guess. There's a group of AI enthusiasts at Starbucks listening to Yashila give a presentation. Let's say location actually. So I told it to extract the property location. I think, oh, oops, Starbucks. Well, hopefully.
It shouldn't be a problem. It does understand it, so you don't need to like craft it without it.
The spelling and
Yeah, the spelling behind it.
Yeah. So in this case, it extracted the entity Starbucks, type location, and then property location.
Super.
Yeah.
Nice.
So yeah. So I actually think that the other example, which I had Llama 3 cook up for me as well. I thought this one was pretty good. It's not super long. You can actually give it a much longer text, I think. I was thinking of testing this out. Oh yeah, are there any properties that, this is like about a restaurant, I guess. New restaurant Tasty Bite has been getting rave reviews since it opened last month. The chef Maria Rodriguez is known for her creative take on traditional dishes. The menu features everything from vegan to gluten-free options to hearty meat lovers meals. Let's say something very something like vibe, which is like very vague. Let's see what it gives us then. Which I guess is kind of like more of a yeah, basically. Yeah, so the other thing that I was thinking of doing with this is like now that you have the entities, you can then ask like another agent to take the original text and then try to construct like relationships between the different entities. And then that should actually not be complicated because you already have like the entities there. So yeah, so this entity tasty bites, and then it's only giving the vibe cozy to the restaurant. Interesting.
So you did not ask for any properties, but it still gave you all these entities. You didn't name any property, right?
I named the vibe property.
Yes.
But aside from that, nothing else. It extracts the rest of it based off of how it's reading it. And the better the LLM that you give it, like the more properties it's able to extract. Okay.
So how did it figure out it's cozy? I mean, just from the text, or was there some cozy mention in the text that it said?
No,
Or from the situation?
it just summarizes. I think also it makes sense to why research in the restaurant.
It does, like the restaurant has a cozy atmosphere. It does extract from there. But
Really?
yeah. I think you can also say yeah, I don't know. I'm forgetting the word for it right now, but I think you can actually also have the LLM try to classify something as positive or negative.
Yeah, like in regards to your point, even if that word cozy was not in the text, it would have still be able to either find cozy or something similar. You know how the LLMs work, right? Like it predicts the next word, and based on like thousands of like books and words and websites, it has been trained. It comes to conclusion that for that part of the text, the best like subject, the best word that matches with that is like cozy or comfy. So even if you eliminate that word, it is still good.
Yeah, come on.
Wait, have you found a way? Because QAI does agent to agent like conversation, right, in the loop. Have you found a way to like kind of control that? Because the problem that I'm having is like they'll call a tool and they'll do all that, but then they'll start like glazing each other. They'll say good job.
Yeah.
And then it'll just loop over.
Yeah, that's my main issue with Korea. I've not found I mean, I think in like the task prompt, you can be like very explicit, like do not ask anybody else like about this, or like reject everybody else's opinions. So Hamad asked a question about like, so in Korea, the agents have a tendency to be a little bit too nice to each other. So they just start like getting into these loops, like where either they're praising each other or they're like, I think so-and-so is an expert in this topic, so I'm going to defer to their opinion. So you get like these like loops where they'll just like not actually do any reasoning whatsoever because they feel that like they can just delegate the task to another agent. And so I think that there is a way to like disable delegation. I think
AutoGen has it pretty well. So
yeah, AutoGen. Yeah, I would say that AutoGen works a lot better in that sense. I think that the underlying prompting system that they have is a little bit yeah, is maybe a little bit more precise, or that they just generally have like clearer prompts or something like that. But yeah,
sorry, no, I'll let you finish your thought. Yeah.
Oh yeah, I was gonna say, even if you say allow delegation to be false, which essentially if you allow delegation to be true, then it can, like an agent can have a task and then actually ask another task or another agent to execute on the task. However, what might end up happening is even if you say allow delegation is false, they might also say, I'm going to think about this for a little bit, or they're going to like essentially like not do any work that round and then get stuck. And then the next round, they may not do anything. And so that also causes like some of these like chains to essentially like not finish, which is kind of frustrating. But yeah, back to your question.
Yeah, so Yashila, thank you. That's a good introduction. Creates a good fertile ground to think more. Would you be able to conjure up a sort of an example beyond this where you can take the next step and say, this is how it would probably break things down. We would need 2 or 3 agents to do this. Maybe it might be route planning, or it might be route planning and booking a ticket. Can you conjure up an example that kind of creates a complex set of tasks?
Yeah, so I mean, one of the reasons why I didn't do that is that there are actually tons of examples doing this in like Korea in particular. I kind of wanted to just like focus on like how to define the agents and how to define the tasks in particular. My code for like a project that I've been working on is currently not running, although I've gotten it to work previously. It's supposed to be like a social calendar like agent that essentially like you can give like whenever you're free and what your preferences are to meet, and then it has like a list of like all your friends' preferences and like their availability. And then it should find like the commonalities between like your availability, your preferences, and then suggest like where you should go. And actually that one also, I like added a tool where it like searches up on like an API that I found that has like local restaurants and like when they're open. And so then it should be able to like suggest like real-time events which are there. And so all of that is possible, and you can do that in Crew AI. Like you don't have to go into like any of like the other frameworks for this. It's just that the controllability of it is like as I was saying earlier, like not always the best. Sometimes it works, and then most of the times it works, and then sometimes for many reasons it doesn't. Sometimes like if the API takes too long to respond, it doesn't wait for the API to finish, and then it kind of just like
So Yashila, you would you with your social calendar group social calendar, you would expect between a set of friends for this chain or this agent group of agent crew to look at your free availability and preferences and go ahead and book events for the next 2 weeks or something like that.
Yeah, or you should be able to ask it, I'm free right now, what should I do? Right? So it can be like multiple different scenarios there. And actually like the same set of agents should be able to do all of them.
And if you want to like mention your preferences, what would be the best way to say? Would that be like to put it in the main code, like these are my preferences, or would that be to like make a new document and upload it? How would you go about it?
So actually the way that we went about it, because we made like a React native app for it, is that it essentially like you could select it as tags, or you could type in your own like on the app, and then it stores it as like a list, and it could be like any number of things. Like you can say, I like to go to breweries, or like I like live performances, and or vegetarian or something like that. And then because the LLMs are pretty good at being able to intuit like what events are appropriate or not, I didn't have to do any extra reasoning there. Like you can have fairly unstructured data be like given to the LLM, and then it can reason off of that as well. Yeah. Any other questions?
So in this case, would it be if, let's just say that there's an API call you can make to get the list of events in a particular city? And so would the LLM make the outside call, or would you have to make the call to get the data from the
No, the LLM can make the outside call through the tools that are available to it. So you can like define tools using LangChain that are available to the LLM within each of these frameworks. So essentially like you can have like an API function, and the API function will take in like a set of query parameters. Then the query parameters would get like formatted into like whatever API call you want to have, like through, like whatever API calling you want to use like in Python. And then you can expose that function to the agents, and then the agents will format like the function parameters, and then call the API through the function. I don't know if that answers your question, but
no, it does. So it looks like you can go both ways. You can make your own calls, or you can define the function through LangChain into saying, and LLM will make the call saying, let me bring the Fremont events and keep it ready and see how I can fill it up for today or for the next week.
Yeah, exactly. And so in that case, like what I ended up doing is like after I essentially like had the agents propose like a series of potential meetups. So I think like 3 or 5 meetups or something like that, hypothetical ones. And then I had like another agent then go query for like similar meetups like on the API itself. So it had like On that API, it had like a few, like it was like somewhat open-ended. Like you can look for like different types of cuisine, for example. And so I would have like the LLM structure the query in terms of like, if one of these is saying that they should meet up for a restaurant, then I should query for cuisine. And the agent is able to do that fairly effectively without making like a really complicated prompt, because it knows that like, if I say meet up at a restaurant, that means that the input that I'm interested in is the cuisine input, right? Whereas like if it's a live performance, I might be interested in like whether it's 18 and up or something like that.
And that
So-
reason in part, that is what justified using a better like model, even it could be more expensive, because that example you just said, with a more expensive model, a lot of those reasoning would be like taken care of.
Yeah, and yeah, exactly. So part of it is also that like you might be able to simplify parts of this, like using like a function. So one of them is like the commonality finder, for example. I abstracted that away into a function because that's a fairly simple like coding problem, right? So like why bother having the LLM do it if I can like code a simple solution? But if like the solution is too complicated and I don't feel like it, then I can make the LLM do it for me.
So in this case, the commonality finder that you mentioned. So let's just say you're interested in going to a blues concert, and in your preferences, you have said you like blues concert, and you want to. Would it find a friend who likes blues at that point in time too?
Yes. So the idea is that also with like suggesting the events in that case, like I had like a sanity check on like whether you would be able to even like ask for that event at that time. Like it's not like you're gonna go to a bar at like 9 in the morning, right? Even if you
Right.
both like your game.
So you can add those additional constraints, saying bar is only after 9 p.m. or 8 p.m. You can do that.
So you can add those constraints if you wanted to, but actually you can just ask like the events planning agent to like not like suggest hallucinated events. Like make sure that this is an event at a reasonable time, or that this event is actually going to happen. And
Also, how could you say I don't want to do like 2 blues events in 1 week?
yeah, so that's I didn't quite get that far because I think that like that kind of leads into, okay, now that we got like the basic functionality to work, can I actually do some like meta behavior on top of like what suggestions that I'm making? That I actually think is really interesting, because like what you can also do is like, if I know that like one friend is like kind of like something, but they're not like fully sold on it, then if they have an event that has like other things that they like about it, you can try to like propose that they go to these kinds of events to like make them like it more potentially. So if like you like going to a blues event, I like going to a rock event, I might be willing to go to a blues event if I'm going with a friend, right? And then I might change my preference to liking blues. But I might, yeah, again, like I might not want to go to a blues event every week. So I think that that's kind of like a meta behavior thing that is also something that I think can be like you can utilize like agents to do. Yeah.
So if I'm introducing a co-star prompt, is it even possible, or?
Yeah. Actually, that's a great way to put it. I would say that co-star prompting is especially effective like in defining the tasks. Like when you're doing like
What prompting
this,
is that? What prompting is that? Co-star?
Co-star. So it's like context, objective, style, tone, audience, and response. Co-star. And then like response would be like the expected output actually here. But you don't need to have like, yeah, that kind of goes more into prompt engineering of like, how do I effectively like make a prompt for an LLM? How do I make it like precise? How do I kind of like break down my prompt into like different aspects that the LLM would kind of use?
So I define it there, is that what you see?
Yeah.
The context.
I would define everything except for the R in CoStar, because the R kind of is like it corresponds to the expected output.
That's the pydantic part, the expected output.
Yes, so you can actually run this through Pydantic, but in CrewAI it's actually not so straightforward. Pydantic is only enabled for like OpenAI LLMs, which is something that I've been meaning to like find a workaround for. Hamat, did you have another question?
We talked about some py data or something. You said py data.
Oh, it wasn't about, is it CrewAI that uses React, or is that AutoGen?
I think both of them are based off of. I know that AutoGen is based off of it, but I think that both of them like have that kind of baked into the prompting style that they have. I also know that like in Llama Index, they have like a very explicitly defined like React agent. Yeah. The interesting part about Llama Index, I think I might have mentioned this last time, is that they actually take some of like the papers which are there on like different types of agents and then just like implement like what the paper suggests the agent should look like. So then that can help you kind of like test out like different like planning styles from different like experimental papers and stuff. Are there any more questions? I know that like I wish I had like a working example of like the one that I've been working on for like the social calendar one, because I do think it is like an interesting example of like the different functionalities that you can have. Because the other thing that like I've seen examples for is essentially making agents that are able to interact with like your Google Calendar. And so from that, you should also be able to see like when people are available versus not available. And if they're like willing to let the agent kind of look through their calendar itself, you can use that as like, oh, they like doing these kinds of things because they're doing it regularly. So you can compile preferences from the calendar inputs.
Somebody was asking for your code. Where can you
Oh
download
yeah. I will
Yeah,
put
it
this
would be
in.
good if you have any zip files and probably a setup little document that we could just run it and see on our own machine. Yes.
Yeah, I'll add like a setup. I'll add some setup instructions to an MD file, and I'll add this as a zip file to the Discord if everybody's on there.
That'll be fantastic. Yes.
Okay. Yeah, do we have any other questions? I know it's getting kind of late. And I also know that this is a little bit of a haphazard presentation. But I hope
In some real world, you would actually use a if you're using Llama Index, then you have the vector as well as can you this Llama Index punch through to a database. You might want to store some JSON or intermediate results and to format it, do something with it. So you would use some local database also, or wherever in the cloud, wherever you want.
So for like the example thing that I had with the Crew AI app, we actually posted all the JSON outputs like into a MongoDB and then pulled that into the like a MongoDB instance that was like hosted on AWS, and then we pulled that into like the app. And also on top of that, like some of these like databases like MongoDB and like AlloDB and a couple of other databases have added like vector indexing search like on top of it. And for that, like you can use like Llama Index to generate like the embeddings and then the index on top of that, and then store that in the database. And then Llama Index also allows you to use pretty much whichever embedding LLM you would like to. And so those LLMs are not necessarily the same as the LLMs that you would use to like do some of this like generative stuff, which is like doing the planning or also like creating the outputs. Some of them are optimized to basically be either as cheap or fast as possible, or try to create the best or like most searchable embeddings as possible. I hope that also answered your question. I think in like real life, you'd be using something like, something like MongoDB, because like you already have that, right? So you might as well just generate all the vector embeddings and then be searching off of it to do some RAG.
No, my case was also for storing intermediate results while you are wrangling it from one function call into the formatting it and sending it to the other ETL, kind of transforming it, sending it to the other one. So you need some local storage.
I don't know whether you would store the intermediates. Oh yeah, sure. Hamad has an answer for this.
So like in the pod case,
yeah, you want to come up here?
Like you wouldn't use
mute.
Do you want to maybe just come up here and chat?
You wouldn't use like
somebody has it. Somebody has also turned on the microphone.
So what I was saying was in like a prod or enterprise context, you wouldn't really use Crew AI or Llama Index or any of these like pure POC abstraction libraries. First of all, because there's no control. And a lot of they don't work off memory, what Yashila was talking about. So you mentioned LangGraph, right? What LangGraph does is it defines essentially a chat state that is like, say, like a tiny database that runs just during your chat session. So as you add a message, whatever function calls happen, memory, tools, everything gets appended to the state, and that state is usable by every agent in that pipeline. So that's what you would normally do, I think, if that answers your question.
Got it. But sometimes, you get, okay, I get it. Everything is probably stored just like a log file. At every state there is a log, and you can just keep on accessing logs or data out of the logs, is how I understand it.
Yeah. So nowadays, I think what has happened is there is a set of like AI storage solution. For example, I mean, a lot of the CSPs allow it. For example, in NVIDIA, we call it NV Mesh. So basically, it's a distributed mesh storage, especially for multi-node inferencing and multi-stage inferencing. So if your inference takes, like, let's say you do a multimodal inferencing where you need to call out like a set of, I mean, basically you can set up like a million or like even thousands of mixture of experts, but you need to store the intermediate states. Now, intermediate states, depending on the kind of inferencing used, there are like three different states, right? Like a file-based storage or block-based storage or object-based storage. And mostly they do block-based, and they are like a lot of AI storage solutions. It's called NVMesh. So most of the enterprises uses NVIDIA NVMesh, or like Azure has its own storage. But it's not like a vector database. It's just a distributed file or a block-based storage mostly.
Got it.
Yeah, and then the previous answer explained, all of these stuff, like most of these framework are essentially for bootstrapping. They're called bootstrapping frameworks especially because of exactly like how it is outlined, because of lack of control and lack of doing like memory-based RAG systems. So what they do is that they quickly take a POC, like how do I take an agent or a goal-based behavior, and I use one of these framework to define it, and you could quickly find out the interface point, so to speak, like how do I design a system? How many times it reaches out? What are the intermediate states? How do I define my cache? And it's like defining actually a distributed system framework, like any other, like you have built. Let's say if you're building a recommendation app system, like not an LLM based, but like a quick recommendation app for suggest me an event, and we want to build an Android app, and that's not using LLM, but just it's an Android app. No, the same step would be followed here. So these frameworks are very good in terms of like understanding the agent and goal and defining tasks to get it bootstrapped. But if you want to become an enterprise product, then you would slowly defining like you need a lot more control, reliability, repeatability, and how the latency is a lot. How do you define your distributed cache? Like then that RAG framework definitely would come with like AliDB, and like Yashila mentioned, AliDB or even Mongo with Atlas. But most of the intermediate steps, they're always stored using either block or object based. And yeah, one such example is NVMesh. You can look it up. It's called NVIDIA NVMesh.
I think also like if you're like working with external agents, say like you have two entirely different applications, because like as we were saying, like this Career AI is not exactly stable enough for like you to be actually using it in production. Yeah, but if you're like actually interfacing with like multiple different agents, say like I have like something that's like running on my computer or like on my phone, and then like I'm trying to like get some information out of like somebody else's app, like then having like a shared vector store might actually make some sense, because then you have like at least like some like a relatively fast way to essentially like pull information like from like a common database that's also structured enough that like you're not like sending like semi like random like requests like in between agents. I don't know. I think
no, that answered it. I think there are multiple options. As someone that said earlier, that you have every state has some DB log to right up to NVMesh, block file or block storage. And then you could have your own super heavy duty, which is AliDB. But in that case, you are doing all the state management and all of that stuff. NVMesh probably has waypoints, just like waypoints, I call it, because, the line graph is giving you waypoints within the DB. So NVMesh probably also gives you waypoints. And LOIDB, you're probably managing yourselves, unless Mongo has also given you some waypoints based on where you are in the execution graph that you could go back to saying, what is this the memory at that point in time? I want to look into it. Yeah.
So Yashila, even the mem GPT provides a lot of memory, right, for all the. Can it be used here? Can it be connected?
So MemGPT is also kind of like one of these POC projects right now. It's not, I would not say it's heavy duty at all. Like it is like an interesting proof of concept, especially in terms of like the idea that it presents. But I honestly don't think that they have executed on some of like the more interesting aspects of like potentially like hashing information through knowledge graphs, for example. So yeah, I don't know.
But can you use it because you can just hook it up and because
not
it's a lot of memory.
Not with Crew AI. I've actually tried to like make some of these agents like be like MemGPT agents because like I guess like in like my idea was that you can essentially like create like wrappers around MemGPT like for like the agents that are sitting here, and then I was like interested in seeing like what like the memory like output would be, because instead of having like a simple like memory scratch pad, it kind of like does a similar thing to like what this agent is doing here, where it like extracts entities and properties like from the text that it sees and then like tries to cache like the most relevant information. But yeah, it's not exactly easy to like pull into Python, and it's only like 2 people working on the project right now, so it's like whatever they were able to get free in their free time recently.
Looks into mem0.ai, something like that.
I haven't,
I
yeah.
don't know if it's knowledge graph based, but you can use it as a tool essentially, because
Ooh.
you just instantiate a client, give it literally your message history, and I don't know if that's what MemGPT did, but it'll just write like a summary. And since it's all simple functions, you can call them.
Interesting, yeah. I mean, yeah, that was kind of like the idea, is that like MemGPT was also doing like continuous summarization of like everything that was going on in the chat, but it's not like it was like like you had to get the whole package, like you couldn't just get like the memory functionality. Interesting. Yeah, I'm by no means like the ultimate expert on any of this. I think that there's a lot of stuff going on like a bunch of different fronts, and so it's like interesting to see what everybody else has been working on.
Yeah.
Yashila, can you share the paper link for today?
There's no paper.
There's no paper.
Sorry,
I'll be
I came
sharing
late.
sorry, zip file. I'll be sharing this zip file, which is what I was showing, and then I'll try to make like everything that I wrote on the I'll make that into the same kind of presentation.
So Yashila, I have a question regarding how do we know we are closer to the goal? I mean, sorry, I shouldn't say the goal, because the goal, this is the utility. How do we know that we are closer to what we wanted to achieve?
So I think for the agents, the way that works is the prompting system like continuously reminds the agents of like what the original prompt is. But if like the agent is like running indefinitely and it has the ability to like summarize like the previous state, which is like what MemGPT does, for example, like if you have like a continuously running assistant and it's like constantly like summarizing what has happened, it's very possible that it'll just start like hallucinating at some point and then it doesn't really know what it's doing anymore, and you'll have to remind it. So, and that's also part of the reason why like in Crew AI and in AutoGen, there are like user input features so that you can basically tell them to get back on task and like remind them what the task is to begin with.
Got it.
Yeah, that is actually, yeah. I mean, I have to like look into how some of like the actual like production style things like LangGraph is like doing in terms of like how it ensures that it's like actually executing on the task that was given. But that kind of controllability is one of like the main issues that I think will exist for agents in general, is that it's like going to be just like, I mean, it's a stochastic machine. It will basically like try to come up with like an answer and generate an answer and then just like kind of jitter off of that in order to like get to like the task output that it's expecting. But that also means that it will have like error and it will actually like deviate from like what it might want to do.
So, even before the agents came out, I was planning last September. I was planning my trip with my wife to New Mexico. And I laid out in Gemini clear things saying, hey, I'm flying into Albuquerque, but getting out of Santa Fe. And route me a plan I'm interested in natural arts, museums. I want to visit Taos and a few things. And these are my likings. Plan me the days so that I can enjoy these kinds of cuisines and all that. Don't put anything before 9 a.m. and after 6 p.m. I want to break for 1 hour for lunch. And it literally planned the entire trip out.
Nice.
So it just inputting, continues to input this back and back and back and refining it through prompting actually. But I wish if there was any agent that I could use.
Well, actually, like one of like the big career AI examples is actually like I haven't tried it, but like the example that like the guy who made it on YouTube gave was actually like pretty decent. Like the output was pretty decent. And it was also like pulling in real-time data, like using Serper AI, which is like, or Serper Dev, which is like it like will search through Google and then like pull up like the top 10 answers. And then I think like use that to like make some of its decisions. If you want to look into that, like that might be good. It's also on like the same GitHub page that I got this from. It's like from the same repository. It has a travel agent or travel agent.
Do you know of any business that is actively using these agents? Or
I mean, there are like a bunch of different like startups, for example, that are trying to use this to basically like create things.
I mean, maybe you could take a look at like the Google open source Oscar as an agent, as a public agent, like a Golang open source. That could be the first agent, which is much more. Because what happens is most of this, when you build agents, also correspondingly you need to think about like the guardrails actually on how the agent, and then the alignment. So there are two types of guardrails. Even yesterday when the Gemma 2 released, they released something called Shield Gemma. So basically, how do you protect the agentic behavior or any kind of LLM behavior not to deviate? So there are two types of behavior. One is this harmful behavior, another is the deviation or hallucination behavior. How do you align back your agent to the task at hand? So there are two types of guardrails being. I think now the current guardrails are something like, there's one called like Llama Guard, which is open source by Meta, and then Shield Gemma, which is yesterday open source by Google. And both of them are actually on NVIDIA NIM. So they just released first on NIM actually. Even the Google, they didn't even release on their GCP. So directly went to NIMs, NVIDIA NIMs. But the thing is that now what is not yet properly defined is, we know the very established like harmful and hate and LLM behavior, but we don't know yet how do you create like controllability or alignment behavior yet. So that's why when Gemma was released, they released like the sparse autoencoder, which was their own open source sparse autoencoders in order to help for much more interpretability and the controllability of agent to align the task, which was one of the paper actually assisted on this. So that was a very good paper to understand. But the current behavior is that, how do you come up with a guardrail that allows continuously to agent to get back to the task without the user input? How do you get it back to a task? That will be defining the production behavior. Because currently the production behavior is limited by how do you maintain the recursive chain long enough such that the subroutines can be properly formed? How do you get the repeatable behavior every time when an agent runs? And how do you?
Are you saying that as the alignment? Is that what you're calling alignment?
Exactly. So that's why nowadays what will happen is, that's what happened when we saw like the small model like Mixtral or like GPT. I mean, GPT didn't do it, OpenAI didn't do it, but Gemma and more like Llama come up with. You'll always see that the model, and then the guardrail, and then the sparse autoencoders. These three things will be released every time when a new model is.
What are the three? Model?
The model itself, that will be like a 2B, 3B, 8B, or 405B. And then the next thing, you will see the guardrails, corresponding guardrails for that model. So Gemma released like Shield Gemma, Llama released Llama Guard, and NVIDIA has like NVIDIA Guardrail, and so on and so forth. And then now the third thing you slowly start seeing is that the controllability aspect of it, like especially the how do they understand what the sparse autoencode is, that is also getting released. So that when people build agents with this, they could actually use them to steer them back. It's basically like a steering control. How do you steer the agent back to the task at hand?
So one part is to avoid hallucination, and the second part is to avoid
alignment, primarily. Yeah, yeah.
Incorrect or like hateful.
Yeah, deviation from the normal, like yeah. So because that, I mean, nobody is still. It's an active field of research. We don't yet know how to control or like keep the model with the same goal-oriented task. So that's why most of the production use case you will see is like mostly open source. Like a lot of startups doing it, but the actual long-term production use cases are. I think Google started in their last I/O. They started this Oscar. Maybe you can look it up. It's called Agent Oscar. OSCAR. So that was one of the first production quality agent that was open sourced. And you will see much more, but primarily in the open source, and then slowly it's up to enterprise.
Who is talking at this point?
Yeah, my name is Kishore.
Kishore. Kishore, hi Kishore, this is Sriram. I had a question regarding, is this, as you said, is related to the earlier paper that Asif did, that was on the mechanistic interpretability, right?
Exactly, correct. I mean, this is the Anthropic paper I think we discussed.
Right. So the idea would be to, let's just say if this task is about getting travel things booking, whether you can guide, just like they ratcheted up the sycophancy features. Can
Yes.
you bias it to make sure that it finishes the task and stays on the task?
Exactly. I mean, simple task is simple, and I mean, most of the simple task is actually kind of like it's almost like the context is built in. But if you want to build let's say you want to build an agent that could help anybody with a trip planning, depending on like different kinds of trip planning, right? Like leisure trip or a business trip or an entertainment or a wedding trip or whatever. There can be any number of trips, but you want to build because in your case you specifically asked for very narrow use case of exactly what you wanted. But if you want to build an agent that could help anybody to do that, then you would need to think about how do I align my agent so that it can help different sort of like trip planning use cases. And you can also add like a lot of optimization constraint. What if you want to plan a trip across the ocean in a different continent? Then there are multiple ways to get to the same trip. And what is you want to optimize? Do you want to optimize time or luxury or like there are different factors you could optimize as well. So what Gemma did is I think they open source this, they call it OSAE, open sparse autoencoders, to help in the decision making when somebody builds agents out of it. And you will slowly see like most of these new models will release their own sparse autoencoders so they can be backported into these things. Yeah, I mean, my prediction is, just my prediction. So in future, people wouldn't even think about these frameworks. You can actually come up with the agent using prompt, like prompt-based agents.
Yeah. And the other interesting part about that is like if they have the like appropriate, like with the sparse autoencoders, like one of the ideas behind it is that like if you can find like the underlying features which like correspond like with the behavior that you want to have, like you should also be able to use that as like its own vector space. So you should be able to select the features of the agent like ahead of time, and then use the sparse autoencoder to like fix the behavior, and then you can prompt like much more effectively. So then you don't even need any of like this stuff because you already know how it's going to be, right? But yeah, the problem is that we don't know how it is yet. So it's kind of an active area of research. And yeah, like the checkpointing that we were talking about earlier, like the other part of this that is really interesting is that if you have like a fixed behavior, you should also be able to fix the embedding space that you're like projecting into. So then you should already know like ahead of time like what you expect to see like with like the if you were to embed like the output like at a particular like thing, you should be able to see that it actually like matches the embedding that you expect to see like here, even if you've never seen this before, right? So
would they like in the example?
Yashila, whatever you say may be already there in the agent when agent SDK or things like that is coming, right? So the agents, you may get the agents as a library where behavior is already embedded into that.
I think you might have that right now through like fine-tuned like models like LLMs that you can place on the back end of this. But Like the point of having like the like autoencoder like features is the fact that you don't need to fine tune it. You can just like fix like some of the activations to like be at particular values. Yeah, I feel like it's also getting kind of late, but yeah, Sam, did you have...
So in the example of concept you mentioned, like it does understand certain restrictional concept, and you don't have, as a user, you don't have to mention, like if there's a concept like 200 miles away, it doesn't recommend that one, but like you don't need to specifically say don't suggest the concepts in that radius.
Exactly, yeah. So what part of it is like if you prompt it to be reasonable, it actually does give you reasonable outputs. And the other part of this is actually creating the strict prompts. I think sometimes will degrade the performance of the agent, because say like you are generally not willing to drive more than 25 miles, but there's a very special event that's like 50 miles away. And if like the agent gives you a good suggestion for like how you'll plan out that day or something like that, you might be willing to consider it, right? And in this case, like one of the things that we didn't fully integrate this, but one of the other like things that I had been hoping to like get as like a feature is that we should have like whether the user is accepting or like rejecting like the recommendations the agent provides, and then you should be able to use that to either adjust the prompt or like somehow adjust the behavior, like get some like real-time feedback like into.
Or if the first suggestion is declined, then agent has to come up with a second one. So
the second one will already be there. So like the way that I had it is that it generates like 3 or 5. And so essentially from there, you should be able to go through that list. And if not, then it'll like have to go generate some more. But the idea is that once it has accepted or rejected like a request, or like you can rate like the recommendation, that you should be able to take those ratings and then use that to either update like the user preferences, like from an agentic point of view, or update like the way that the agent is performing. Because like if the agent is consistently bad with like all of like the users, then it means that there's something wrong with the agent.
The future suggestions would be better.
Yeah, so the future suggestions would be better. But then if like I am only getting something wrong for like this user, maybe they didn't actually list their like preferences correctly. So yeah.
Great, really good present. Very interesting
Thank
stuff.
you. Yeah, I mean I feel like there's from like a making products point of view, like there's a lot of work to be done in figuring out exactly like how to balance this with existing technologies which are there. Like for recommendation systems, those have been around for a really long time. So like what part of this should be should you have the agent do, and what part of this should just be a part of like a natural like classic recommendation system? And yeah, again, it's also true with like the databases, like doing like indexing based off of like the words is faster than indexing off of like the vectors. So like where would you do like a vector like retrieval, or where would you do just like a basic like word search is kind of like, I don't know, like these are all like questions that you have to actually deal with like when you're making proper products. And yeah, how do we integrate these? And like one of the reasons why I was talking about like the stability of these things, and also generally like we've been talking about stability, is that we want to kind of break these out into modules that you can actually call from applications, right? And in a proper application, because it's like a deterministic system, it has to give you a good response every time. And so in that case, you do have to actually come up with unit tests. You do have to come up with like latency like requirements and stuff like that. It's just like a practical part of software engineering. Yeah. Yeah.
Hey, Yashila, I didn't follow that sparse encoders and alignment controllability. How are they related? I didn't get that.
So in that paper with Anthropic, what they did is that, and this is something that I tried to do with another model that I made, but it didn't really give me very good outputs because I did it in a very naive way. But you can take like these neural networks, right? And then one thing that they've been doing for quite some time, like since they basically started making neural networks, is that like whenever you have a neural network interpret a piece of data, you can take the activations that has within the neural network, which is not the output, just like the way that the neurons like kind of like light up like in the system, and then essentially use that as like a vector proxy for the data that you're seeing. And so something that already existed like for quite some time is that with like especially like computer vision systems, they take like the last 3 layers or the last 5 layers or so, and then take those activations as like a vector, and then you could use that to find the similarity between images like according to a particular model. And so even when we have like vector embeddings here, like we're doing kind of something not quite the same, like whenever we have the vector embeddings like for LLMs, but you can kind of like do something very similar where you look at the activations and then you try to see, okay, well, if these activations are similar for one input as they are for another input, maybe like the model thinks of them as the same, like generally speaking. But the thing is that it's not actually like a linear space that you're looking at. Like so what I tried to do there is that like if I take like a bunch of like activations like from a bunch of images from like the last 3 layers, I can run something like what is it called? Like I can run like a compression algorithm and try to find like the eigenvectors of the space, which should correspond with like, so yeah, if you're like,
are you talking about quantization?
No, not quite, but it is kind of similar, like mathematically speaking, but like it's not quite the same. So quantization tries to have like the same behavior, but you have like a smaller model. But in this case, like I'm trying to take like all the, so I have a bunch of images and then I'm like transforming them into like the activation. So like when I have like the model, I send in an image and then it like lights up in a particular way at the top. Right? Like, and then all those values that are associated with the neurons, I'm taking those out and then I'm using that as a vector. And then I might have 100 images, so I'll generate like 100 vectors of the activations. So then I might take those activations and I might try to see like what is most important to this model in terms of trying to figure out how they are similar, right? Or how they are different. So in that case, I can take like the singular value decomposition, which is like a really fancy way of saying I try to like imagine this in space and then see what variables are like the most related to the way that like the vectors look like in this space. And then in that case, if for example, like I did that singular value decomposition and I look at like the main dimension, like the first dimension is usually associated with the most important thing to those images. And in this case, it might be that I see like a particular color. Or I see like that it has like a big, like the background is one color and the foreground is another color, or that it's like you have a certain type of contrast, or you see like certain shapes or something.
Texture.
Or texture or something. Yeah, and it can be any number of things. So I don't actually, one of the issues with like a lot of this alignment work is that I don't actually know what these like dimensions are. So that's also one of the things that they talked about in the paper is that now that I have found like the most important vectors like in the space, the most important dimensions, how do I come back and try to see what it actually is, right? How do I know like this is something or the other? So
this reminds me of convolution neural network.
Yeah. So yeah, going back to that thing is that I tried to do that with like singular value decomposition. And the other interesting part about this is that this isn't a linear space actually. So what they in this paper, like that's why they use sparse autoencoders, is that it's another way of you essentially doing compression, trying to find the most important features here. So like what are the colors, for example? Are the colors the most important, or are the shapes the most important, or is something else the most important? And then how do I kind of figure out like what those actually are in real space? So they were able to use the sparse autoencoders to essentially like figure out the features and then also try to figure out and then also kind of like they labeled them with like specific with kind of like their general understanding of like what that feature was. So they found one feature that was associated with the Golden Gate Bridge. If you like if you took that activation space and then you took those features that were associated with Golden Gate Bridge and then you always turned them on. So in the neural network, this is like instead of letting it just like generate something, I'm like fixing all of the neurons that I think should be fixed in a particular way to be always on. So like this is like for us, we are always thinking about a particular topic that's always firing those neurons, right? And so if I have like Golden Gate Bridge like neurons activated, everything I say will be about the Golden Gate Bridge. Everything. Or if I have like the psychophantic one activated, I'm always going to be praising everyone around me. And so the interesting part about that paper is it showed that actually like I can discover like particular concepts and then also how to like activate those concepts within like Claude 3 model, like within the Claude 3 model. And that is like really fascinating because we've never been able to do that before. But then it's still kind of unclear exactly like how closely it's aligned to these concepts. Like, is it actually the Golden Gate Bridge? Or is it something else about the Golden Gate Bridge that is being activated? Like that's a little bit more hazy. And then like, what if I was really, really interested in like coming up with a feature for something very abstract? Say I'm really interested in like, I don't know, like gold edging, like in decoration. Will I be able to find a feature for that? I don't know. Or will I be able to combine different features to get it? I also don't know.
But if you provide thousands of examples of that feature, the AI model may be able to actually detect that. But then the problem remains that we may not understand what exactly happened in those parameters and we know that was able to make that distinction.
Yeah, exactly. So Sam was kind of saying that like, even if we know that like the AI was able to like see thousands of examples of this and we know that it's in there, we may not be able to, what was the second part about that?
Interpretable, we may not able to understand like what exactly went through the model to come with that conclusion or with that distinction.
Yeah, exactly. We don't know how like the model is actually training that information like into it. So yeah, there's like lots of different research to be done in this space. And yeah, like again, like if we're interested in really, really specific features, we may not actually know how to extract those features in particular. Like right now, like how it works with the sparse autoencoders is that they're just like training whatever they can get their hands on. And then we're just assuming that that's going to be like all we can get like out of the sparse autoencoder. But if I'm really interested in a given type of behavior, like how do I get the sparse autoencoder to like extract like the features for that behavior that I'm interested in? I don't know. Yeah, that paper was really interesting. There's another follow-up paper by OpenAI which looked at something similar. Like they tried to use another smaller LLM or like similarly sized LLM to like extract some features, and they did not have a lot of success with that. Yeah, but it's interesting that like the Anthropic paper was also reproducible like by other groups who were able to like make their own sparse autoencoders as well. Because I do think that at least you have something now. Like at least you can find some of the activations and like some of the features that are there. So yeah. Okay. I think it's getting really quite late now.
We should go.
Yeah.
But thank you very much for presentation.
Oh, thank
This was
you.
very,
Yeah.
very informative. Very
Yeah.